All right, trend logs and histories. There are about half a dozen different names. Different companies call it different things, but it's all the same thing. We're recording data, okay, at a periodic rate, usually. Trend logs are really, how are they useful? What do we use logged data for?
Look back in time.
Look back in time. I love that. If you get an alarm that's generated overnight, nobody's in the building, somebody comes in first thing in the morning, how helpful is it to be able to look at what's happening right around that alarm in time period? What happened leading up to it? Give you an idea of what happens to help you fix it, right? It's helpful for predictive maintenance purposes. Hey, we look back in history, and you can consider alarm logs as part of the histories for your building, right? It's a history log of the problems you've run into. And if you notice patterns in those logs, every Monday morning, my low limit trips, if it's below 20 degrees outside, on air handler 1. That's a historic problem. You can start predicting that problem. You can start addressing, okay, now we need to find out why that's happening. Okay? Histories and logs are a huge diagnostic tool. They can also be really helpful for reporting purposes. Okay? Especially if you're logging things like your building's energy usage. If you've got BTU meters on your chilled water, for example, or you're monitoring your electric meters or your gas meters. All of that kind of data, it's great data to have in your system, but again, what use is collecting data if we're not going to do something with it? Okay? And I will acknowledge guilt in this situation, and it's a problem our industry largely has, is we collect and log huge amounts of data that nobody ever looks at. Just in case we might need it. You're absolutely right. Okay? And sometimes might needing it is more than enough reason to collect that data. But sometimes that data just really does get collected. Your power meter data, if you're logging that, you better have a plan to use it for something, because that's not, I mean, sure, you might catch some data point that would be useful in a troubleshooting situation, but the chances of that, pretty minuscule. Okay? So, has to be useful. Figure out how it's useful. Most of the times it is. Okay? How can it be displayed? Okay? Are we looking at it as a table? Are we looking at it as a graph? Are we comparing two values in the same table or graph? Or are we just looking at them as separate graphs? The more you can compare this data, usually the more useful it is. Start seeing patterns. Start seeing gaps between things that should be really close together. Can be indicative of problems. Right? But you got to have a way to look at the data. Okay? Just dropping it into the database and expecting somebody to be able to deal with it, unlikely. Bob?
Put this on trends. You know, something for everybody in here, because not everybody's got a ton of experience with trends. And that is kick around the most common, put together a sheet of what are the most common trend comparisons we want to look at. And just get that and make it almost like a core curriculum, so, we do for BAS.
I think that would be a great idea. It would be a great thing to implement as part of a larger project. If you've got a student who's programming VAV boxes, or you've got them programming boxes as part of their class, include those logs. Include the alarms as well that would be useful for that piece of equipment. I think that's a fantastic idea.
Yeah, if everybody here has guidance on what trends to set, on whatever equipment they have, that'd be kind of cool to.
That would be.
That's Ted's idea. Gotta give him some credit. Or he's like chewing my line again.
Sorry, wanted to make myself a note on that. Okay.
I'll see if I can set something up in our shared folder for people to start logging information right now.
Thank you, Ted.
I've been in the commissioning field for 15 years, and I tell you, the problem normally is everybody runs to the alarms.
Mhm.
Alarms just tell you you have a problem. The logs tell you how to solve the problem.
Yep. What caused the problem, how to solve it,
Yeah. So
how to avoid it next time, sometimes.
That's right. Right. So the alarm should only be there, like space temperature, comfort cooling wise, never alarm. Use the trends to see if you have a problem. You only alarm for space temperature on critical areas, like cabin rooms or something like that. That's critical. Never alarm on space temperature, on comfort cooling, because who cares if it is actually out of line? You want to solve that problem by the historical trends you can look at, but do you really need to know? I mean, the document's going to tell you.
True.
So, minimize alarms is really the key.
I do not disagree with that last statement. Minimize your alarms. Create the alarms you need to have. Using histories is a much better approach. But that is also a conversation you have to have with the people who are going to own and operate the building. They may, you're right. Occupants are going to tell you if they're uncomfortable. Some groups may have the resources to be a little bit more proactive with it and may want to do an alarm on a room. That way they can deal with the problem before the occupants know that it's there. Because everybody's definition of a critically controlled space is different. Everybody will agree, data center, wiring closet, those, we all agree, those are important. The refrigerator, the beer cooler, right?
But the key is the trend logs are going to tell you how to fix the problem.
You're absolutely right. Absolutely right. The trend logs are key. They are such an amazingly useful tool in the technician's tool bag from a building operator standpoint, from a service standpoint, but they rely on being properly set up on the front end.
One of the biggest nuisances is if you have a chiller go down and it's the only chiller in the building, and you have all of a sudden 800 zones go out of temperature range, and you get 800 alarms. And
Yes.
This thermostat, this zone is out of range, this zone is out of range.
I-
How cool is that?
You're absolutely right. Change the automation. I like that. But you're right. And there, we could come up with any series of catastrophic events that could effectively trigger almost every alarm in a building. And is that helpful? No, because it's always started with the first domino. So, you're right. There are arguments both directions. Again, I'm going to push back on saying you got to talk to the people who are going to live and handle the building. Live in and handle the building to be able to solve it. If they want it or if they don't want it. They're the customer. So, where are we going? How they can be displayed. Is there a way to get the data out of the control system? Or I should say, there better be a way to get it out of the control system. Because, even, unless you're working with a control system that has advanced data analytics tool sets, most of our control systems honestly don't do that great of a job of displaying historic data. Line graphs, bar graphs, that's about as complex as we get. Being able to throw 10 data points on a single graph, sure. Most of our systems don't do things like 3D graphics as far as trend log analysis and things like that. There are some that are starting to develop that or have developed it. Train and Siemens, I know, have. Johnson probably does.
Not yet.
In the works.
I think so.
Okay. I know Schneider's is in the works. No. Okay. But, so being able to get that data out of a system. If you're recording, again, back to that electrical meter data, that's not something that you're typically going to use in the system as effect unless you're dealing with like demand or time of use type stuff. But it is something that's probably going to be useful to report to people on a monthly basis. Maybe you're just comparing it to the data that you're getting from the utility. Maybe you're using it to plan for various things. Maybe you're using it to verify your return on investment for an energy upgrade being done, or that was done. Reporting that out on a periodic basis is a common tool within most control systems. Okay? Being able to back up that historic data. Okay? Most systems have a limited quantity of storage, or limited that they give us access to. Some of the larger corporate systems don't actually store that data internal to the system. They rely on an external database. Those typically have a much larger capacity. Okay? But if your system doesn't have a lot of capacity, you better find a way to back up that data if you want to maintain it. Okay? And clearing space in the database could be critical too. Some older control systems, when their history log database filled up, they just stopped recording data. That was a great discovery. Hey, I got an alarm. Let me go to the history logs. Oh, it stopped logging 2 years ago. Great. Okay. More modern control systems don't deal with that. They start overwriting the oldest data, kind of a rolling track. If you think about like the treads on a bulldozer or something, it's a rolling data. So the first in is the first out. Okay? But you've got to be aware, how does your system deal with it? Where are your trends getting stored? Depending on your system, they may be stored in the VAV controller itself. They may be stored in the supervisory controller. They may be stored on a building automation server or an external database.
You gotta argue with your IT department to get space.
Always true. Okay? Yeah. Okay? Where is it stored? That will affect how you are managing that stored data. Again, back to questions to think about when you're setting up trends. This is maybe as complex and important of a conversation as alarms. They're certainly a useful tool, a critical tool for running a building as far as I'm concerned. But for everything we're looking at, what kind of data are we logging? Are we logging temperatures? Are we logging statuses? Are we logging electrical usage? Are we logging pressures, humidities, CO2 levels? What are we logging? Okay? That will affect what we want to do with it, how we're going to record it, how much space that data takes up. Okay? Things that turn on and off, they don't take up a lot of data usually for trend logs. Things that are temperatures, analog values, those frequently take much more data space. Okay? Again, along with what kind of data, how frequently does it change? Okay? Outside air temperature, room temperature, pretty stable, right? They're not changing every 3 seconds most of the time. Okay? So, how often do we need to record it if it's not changing frequently? Do we need to log it every 1 second? Do we need to log it every minute? 5 minutes? 15 minutes? That's a hard thing to quantify. You want to get it as granular as you can, but it needs to be useful. So if your room temperature is fairly stable, it's only changing, 1/10 of a degree every minute, maybe 5 minutes is good enough. When we see a 1/2 a degree swing, that's pretty close, right? Is it a discharge air temperature that can change literally from maximum to minimum in the amount of time it takes to stroke the hot water valve open? 90 seconds on average. Maybe 10 seconds if it's a pneumatic valve. Okay? Do we need to log that every minute or faster? It absolutely has. It was. Older systems had very limited resources. And frequently, if you come back to where we're storing data, if the data is being stored on like the VAV controller, that has significantly more limited resources. Okay? So that's all a factor. That
This whole discussion, to me, comes back to, in our program, what we do is we have a class on measurement verification.
Mhm.
And so all this type of thing is covered in that class. As goal is trying to work with students to find out why would we do this. Finally, it doesn't always say feel very well.
Yeah.
Even though it's like half the class. Talk about.
Well, sometimes until they get out in the field and start experiencing it, it won't. I mean, how many people have tried to teach superheat and subcooling to new students? How often does that stick in? Come back 2 classes later, you still don't know how to do this? We did it last time, and the time before, and the time before. Yeah, sorry. Robin.
So I guess I go back to this being 10 years behind the time.
Yep.
This is 2 years old, 3 years old. It holds 2 terabytes.
Mm-hmm.
I can hook it to a Raspberry Pi with a SQL server on it.
Mm-hmm.
And I should be able to store the information from this building and probably all 25 buildings on this campus for 10 years.
Mm-hmm.
And,
Yep.
and we got to get over this idea that we can't store data. And we've got to get over this idea that, we only want to store data that we need now. Because that's the key to making things more efficient, is actually going back and going, we discovered something in this building that has been happening for years. And I just, we're not data analysts, and we're not going to be data analysts. But we do still have some people who can analyze data.
Yes. And we are going to touch on that topic. I am going to point out that it's not just storage capability, though. Remember, the device up in that ceiling, VAV box, has usually about 20 to 50 points that we want to log. So, from a storage standpoint, that shouldn't be a problem. Except that we're dealing with technology that's 10 years old. We're also dealing with a processor that's 10 years old, so it may not be able to run all the stuff we need it to operationally and store the data. And we're also going to be pushing that data out through a communication bus. And individually, it may not seem like a lot of traffic, but when you stack up 30 or 40 controllers on a bus, it can be significant. And yet I 100% know where you're going to go and agree that all of those things are changing for an improvement, and you're right, they are. But we also have to train our students to be aware of these topics, because these systems exist for long periods of time in a building. If an owner builds a building for $5 million and pays $200,000 for the control system on day one, they are not going to want to spend $500,000 or $700,000 on year 5 to put in a new control system. I mean, it just doesn't make sense for them. The system that is there has worked for 5 years, will work for another 5 years or 15 years. Okay,
I just have a really cool story, if I may share.
go for it, Jenny.
It fits with the subject, and you're helping clarify again something happening in our building. Today, our staff is meeting and our leadership is meeting with the company to look at a battery storage system. So the Great Lakes Energy Education Center is our building name, and it's got a bunch of solar on it that we don't get paid much for when we export it. So we have this grant to put in some energy storage. Well, when we're trying to size that system, guess what we don't have? Data trends that go on a daily basis or back far enough, which when they set up the system, I was excited to have that kind of thing. But now your discussion is kind of teaching me what the limitations were probably on that network.
Yep.
I was thinking about your storage system, your servers store this data on the cloud, but there's bottlenecks, right?
There are.
Network.
Yep.
10 years ago, we were still watching cat videos. You know, that's the thing. I always go back to the cat videos because, you know,
But
we've got
remember, you got to compound that. 10 years ago, yes, we were watching cat videos. What were we doing 20 years ago? Because that's where the controls were from an IT comparison. And as much as it sucks, and yes, it needs to change, it is where it's at. Lanny.
So one of the things that I do, because of the trending, and you know, when you get into a class and you don't have that information, students look at this white bar systems, we need to store all of it as well, everything.
Right.
Actually, what I do is I use weather data. So I tell them, okay, let's look at the last 10 years of weather data and how could that impact, you know, building and control system. So that kind of gets them going and, you know, looking at historical data and kind of help them out to analyze building now versus, you know, 10 years ago, 20 years ago.
I love that idea because that is something that is easily accessible and something that we have done a good job of tracking for a very long period of time.
What's your favorite source of weather data?
No,
No?
just go to NOAA.
And I never like to use a system that I'm trying to fix, but that's, you know, give me the data back essentially. But is there any good analytical tools, separate analytical tools that you can run independently, but go through BACnet to get the data? You know, like it's sitting there, it's using BACnet as a means to get the points,
Mm-hmm.
but it's analytically doing this then trying to.
Yes. Yes. There absolutely is. And there's a really good example of that in what Train is doing right now. They will come into your building. It is an ongoing service. If you want more details, I can put you in contact with a guy because it is really interesting how they're dealing with this and what they're doing with this. But they are doing exactly that. They are putting a BACnet appliance within a building, sucking up all the data directly off the BACnet network, tossing it up to their cloud for very significant data analytics.
Because, you know, the control companies are there to control, they're selling product to control equipment.
Yes,
They're not selling a product to basically analyze other equipment, you say.
absolutely
They're always
correct.
behind the times greatly on tool capability.
Yeah.
It
Or-
almost needs to be a third party.
And there are third parties that are doing exactly the same thing as well. I pointed out Train because I've got an adjunct who works for him. But Bob.
We have a guy at our incubator, it's called Innovation Advantage, and he came in, we set up 27 controllers, and I combined all of them and created all kinds of traffic, so we could test it. But they go into Costco's and they scrub all the BACnet data, and they're looking for anomalies in the crate alarms, so they don't lose, you know, 25,000.
Mm-hmm.
And that's happening everywhere. It's all
Yeah.
over the place. But that's it. We're just pulling back the data. Those same folks in Berkeley that were
Yep.
with Frost, they were
Yep.
crashing the school servers just because they were scrubbing the data way too much. everywhere else.
Trying to get too much out of the network, crashing it. Okay.
Yeah, that's there. It's there now.
Yep. Another two specific notes on that direction, specifically because Bob brought up the idea of trying to pull too much data and crashing the network. And back to our bandwidth standpoint, remember the bandwidths that we talked about yesterday were theoretical bandwidths. Okay, on an MSTP trunk, two-wire communication, in theory, we can actually get a lot of data throughput. Okay, but in practice, because of how the network gets installed, the physical size of the network, the number of devices, each of those things, the quality of the terminations is a huge impact. Any of you who've met Brian Lovell, you know, consistent quality terminations. Okay? But those types of things all limit the data throughput of the network. And even with this building, which is 5 years old, the MSTP bus in here still runs at less speed than your modem did in the late 90s. Okay? When I set up BACnet MSTP networks, I don't care how small it is or how few devices, I cap it personally at 38,000 baud, bits per second, or 38 kilobits, because that's a stable number. Most BACnet MSTP trunks max out at 76 baud, or 76,000. Okay? So that's really, compared to what we're used to, because of this, and because of this, those are tiny data rates. So it is definitely possible to overwhelm them. So just something to be cautious of. I think there was something else I was going to say, but I lost it.
I know with the EZIO implementation, you don't know there's SQL packages in there.
Only in the EZIO controllers.
It's only in the EZIO
Correct.
controller.
Yep. Yeah. It was something with... It'll come back to me or it won't. Okay.
I never understood that. There's something fascinating with themselves. Them going like another 25, 30,000.
Yeah.
Like 117 or whatever.
Yeah. Yep. Yeah, I'm with you. But
That's unstable too. We'll talk about that.
Correct. So, pulling data out of systems. Oh, BACnet, and pulling data. Because you asked specifically if we could do it with BACnet. And yes, we can. We can also generally do it very easily with LAN. Where we start running into issues with that is when we are running into proprietary communication systems. If you can't jump on the network and pull that data in the first place, it becomes very challenging. So Johnson Metasys and N2 systems are one of those classic examples. If that's what they're communicating, you can't necessarily pull that data originally, and you're going to rely on the data that's being pulled from the system, which, to your point, if the system's in a questionable state, how can you rely on that recorded data? So you're correct in that in some systems, more modern systems, the last 15 years or so, it's pretty easy. It's definitely doable. If you get older than that, or systems that were originally installed before that, and then even expanded even into the last few years, they may still be running that proprietary communication bus. Okay. I got off track. How much storage capacity does your system have? We talked about that. Is there a limit on the number of individual points you can trend within your system? Depending on how your system is set up, that may be an inherent limit. Again, this is something that typically applies to older systems. Is there a maximum number of records per trend? Our contemporary controls controller, I'll show you the chart for how much storage you can have on each trend, and they set it up and tell you, if you're logging it once a minute, this is how many days of data it will store. I think is a really useful graph. Some, other controllers, because they are using a background database or something, can effectively store infinite data, as long as your IT guy is okay with clogging up the server. Another thing to keep in mind with that is some of these systems weren't really designed to try and save an infinite amount of data, and so sometimes the programmers got lazy with how much storage each data point took up, or were inefficient with how much data space it took up. So you can actually end up with an immensely huge database that's clogged up with not necessarily that much information.
What about your bandwidth? It just, how many problems do you have if you're pulling across and jumping across both the networks?
Yes,
Yank data 24/7, and you're not localizing.
correct. And that kind of gets back to that BACnet conversation of how often is our supervisor pulling data from the VAV, or is the VAV pushing it when it changes, that sort of thinking. So yeah, bandwidth should always be something we think about, and especially if we are using a local trend on a controller and pulling that entire trend from the controller for backup purposes, long-term storage, or if it's just a BACnet trend that we can pull over through BACnet. That is going to take up way more space, more bandwidth to get it over than just pulling the information from that sensor. I'm not going to say there's one fixed answer for this problem. Each company has a differing solution. They're all similar, but different enough that it's hard to say. Okay. We talked about what happens when your system runs out of data space. Is it just going to start rolling over the oldest data? Is that acceptable to you? Do you need to keep 10 years worth of data storage? Some facilities require that kind of data storage capacity. Some military facilities that I worked on had to have 10 years of back data guaranteed. If you couldn't guarantee that, they didn't talk to you as far as systems go. And do we need to report our trends on a periodic basis? All of our trends or some of our trends? Back to sending out that report about your electricity usage. That kind of thinking. Anybody care what the room temperature is in this building or in this room? Do we need to report that on a periodic basis? Probably not. BTU usage, energy usage? Yeah. We've got a lot more people starting to look at that kind of data. Cool. And where are trends going? This comes into things that we've already started to talk about in this discussion, and I love it. Data analytics. Big data was a huge buzzword in the IT industry about, 10 years ago. Hey, guess what we're starting to do in building controls? Big data analytics. We've got third-party companies that have been trying to get into our systems to do this kind of thing for years. We're starting to see the big corporations within the controls industry doing it in-house. It's stuff, again, we're playing catch-up instead of trying to be ahead. Okay? So it's there, it's on the doorstep. We are starting to adapt that idea. And Robin said something that I partially agree with, partially disagree with, in that we're not going to be training students to be data analysts. Okay? Yes and no, because we have to teach them enough to be able to look at a set grouping of data to be able to use it to solve the problems either when they happen or before they happen. pattern recognition, that sort of thinking. Are we going to teach them to be able to analyze all of the data in this building and compare it to the data from that building? Not really. Maybe from a 90,000 foot screaming by view of, yep, this building used this much energy per square foot last year and that one used this much per square foot last year. Kind of that level of comparison. We're not going to teach them SQL queries to pull data out of a database to do deep analytics. IT already does that. They have people who have been doing it for years and are very good at it. Why not stand on their shoulders, use the tools they've created, or let them use the tools they've created and pay them a minimal fee, and we'll mark it up to our customer. Okay? And the other big thing that we're starting to use Histories for is automated fault detection. This is one of those points where we are thinking about trying to be ahead. Instead of being reactionary, we're trying to be proactive. There we go. Okay? So the idea of automated fault detection is, instead of just your building telling you that it is broken, it's going to give you that warning message, hey, 2 days from now, I'm probably going to break unless you address this problem. Or finding little problems within buildings like, is that room temperature sensor accurate? Dealing with sensor drift, dealing with discrepancies between two sensors that should be reading about the same number. Okay, why aren't they? Yep. Or looking at, okay, we were at, all of our dampers were on the VAVs were 75% open yesterday, and our fan was at 75% speed. We had 1 inch of duct static. Today, they're all open at 75%. Our fan is at 75%. Why do we only have 0.8 of an inch of duct static? That sort of thing that, an experienced operator who knows their system may look at something, be able to look at it and go, we need to go look at that. Something's wrong. Kind of taking that and using all the data we collect to synthesize that intuitive knowledge that people have of their buildings. Okay? We've had great discussion about the trend logs. Don't shortchange me now. Give me questions. What do you have?
This is a question specifically about the BAS view.
Okay.
It's got 4 USB ports on it.
Yep.
Can we use those USB ports as a data storage facility?
I have absolutely no idea. But it's a great question. There we go.
And so this, we can set that up in here?
Yeah, if you need extra storage, then just back it out. What you got. And I think our Raspberry Pi has that same level.
Mhm.
What I want to
Yeah.
ask is if you can use it as a gate, you have a USB. I don't think so.
Go to that.
Hmm.
USB. What's that? To use the USB storage?
For serial, 45, like a 45 or 422 gate.
Um,
If you could use one of those through that.
I think you actually can, because for a while they pulled it off the site, but they had a handful of different flavors of the BAS view, and a couple of them had a built-in RS-485 port. So they could do direct to MSTP networks, both BACnet and Modbus.
They may do it off the GPIO port though, rather than the USB port. But you might be able to.
Also possible.
But if you can't set the communication parameters, you're not going to be able to use the gate.
Yeah.
And they probably
But-
want to use their gate. That's-
It could be. They could have decided that using their gateway was a more feasible business option for them. But yes. I know that that is within the capabilities of a Raspberry Pi, and like I said, for a while they were offering it. Okay. As far as what the real expandability options are on what they're doing here, knowing what platform they're building off of, man, the sky's going to be the limit. It's going to depend on where they decide to take it, or where we push them to take it.